Next, two identical capacitors A and B are charged to the same potential V and are connected in two circuits at t equal to 0 as shown in the figure. The charge on the capacitors at time t is equal to R respectively. So here diode is given to you and the charge capacitors are connected like this. Here the positive of capacitor plate is connected to P junction and here it is connected to the N junction. And now you want to find out what is the charge on the capacitors at time t is equal to RC. So this is the RC time constant which is given to you and you are going to determine what should be the charge on the capacitors. So is it V into C or VC? Second is VC upon E and VC. Third is VC upon E. And fourth option is VC upon E and VC upon E. Okay, now let us see what the answer for this is. The answer is D, that is VC upon E and VC. Now let us see how to solve this particular problem. You are given the RC time constant. It is the time in which charge on the capacitor decreases to 1 upon E times of the initial stage or initial charge, which is called as the steady state charge. In figure 1, PN junction was in forward bias condition and in that case current will flow through the circuit and that is why charge on the capacitor is going to decrease. And in time t, the charge will become Q is equal to Q0 upon E. Again, Q0 is equal to CV, which implies Q is equal to CV upon E. In second diagram, the PN junction diode was in reverse bias. Now in this case, no current is going to flow through the circuit and hence charge on capacitor is not going to decrease or decay, and therefore even after the RC time constant, the charge is going to remain same, that is CV. So this is one new thing that has been introduced. You have to remember what is the RC time constant and what happens when RC time constant has been reached. That you have to remember that the charge on capacitor decreases to 1 upon E times of its initial charge. So if you know this fact, then only you can solve the MCQ as we have solved it.